Can you hear me? Hello, good morning, ladies and gentlemen. So I'm going to speak about digital terrestrial television, not so surprising today, with a focus on DVT and DVT2, what it allows to do and how to deploy it. So I will first start by introducing Enensys as a company, very briefly, then give an overview of the DVB deployment in the world. I will say a few words about the technology itself, and especially about the improvements that are brought by DVT2. And last but not least, I will explain how to deploy and how to set up a DVT2 system. So Enensys is a company based in Rennes, in France. We are based in the heart of a digital TV cluster. In Rennes, there are a lot of companies based there. And we have a fast-growing path at the moment, thanks to DVB deployment in the world. We have two lines of products. One is broadcast products. The other is test equipment. So I will say a few words about that right away. We are having a business worldwide with partners on the 5 continents. And we have a lot of activities in the EMEA region, Asia, and also a little bit in the Americas. We have a strong focus about technology development, so all our technology is developed in-house. We innovate. We have a lot of world first in the company, like the world first DVT2 gateway, the world first DVT2 deployment in UK, and many others that allow to keep us ahead of the DVB-T2 deployments. And we are involved, of course, in standardization bodies. So going to our product lines, here it's the broadcast product lines. We have 3 sets of solutions. One is network adapters to adapt IP networks to SI networks, for example. Network availability is one of our strong focus as well, in order to ensure that the network is 24/7 available with redundancy management in a seamless way. And we also have transmitter side solutions using DVB technology in order to deploy on the transmitters the solutions that we design. We have first-class customers like, Arqiva, TDF, all the major broadcast groups in the world, telco operators as well. So we have deployed hundreds of systems worldwide. Our test product line allows to do some generation of streams, analysis, and monitoring. So it comes either in standalone boxes or in USB pods. You can set up test systems in the lab or in the factories in order to deploy some systems to make the testing. So a lot of set-top box manufacturers are using that, chip makers as well, and broadcasters in their labs are also using our equipment. So let's go now to the DVT2 market. So DVT2 has been designed. It's in 2007 and 2008 as an improvement of DVT. And well, let's first go to the basics of why going digital. That's a good question. Well, first, spectrum efficiency, of course, is an important motivation. It allows to gain up to 6 or 10 times the bandwidth compared to analog. You can double that with DVT2. So obviously, you can make much better use of your spectrum resource using digital technologies. Second motivation is the quality of service. Digital television is proven to be very high quality, both in terms of video, but also in terms of sound. So it allows to deploy HD TV, to deploy 3D TV now, and advanced interactive services as well, thanks to digital technology. And a third motivation, which can also lead this kind of deployment, is the power efficiency. digital broadcast is much more efficient than analog in terms of power efficiency for the same coverage. And well, depending on a lot of factors, but usually it's accepted that the power efficiency is about 10 times higher in digital compared to analog. So it allows also to gain a lot of power if you switch the analog by digital transmission. So the migration all around the world is in progress. It's in progress worldwide. Here it's a map which is updated very regularly on the web, and which shows the countries which are migrating to digital. So in red, all the countries which have completed their migration. In yellow, the transition is in progress, and well, some countries are undetermined, but basically all the countries have international agreements that allow to force this migration, which is pushed also by the spectrum resource requirements that is pushing a lot to go digital. In terms of standards, what is used? So there are several standards that are coexisting all around the world. I will focus on DVB. So DVB is the blue here. So light blue for DVT2 and dark blue for DVT. It's estimated that overall the market of DVB is around 50% compared to the others. The others, which are ATSC here in North America, ASDVT in South America and in Japan, and DTMB in China. So DVB is definitely the leading digital broadcast technology for terrestrial networks worldwide. This started to happen in terms of DVT2 deployments in late 2009, early 2010. So the first deployment of DVT2 networks happened in UK. It was led by BBC, who is behind DVT2, pushed a lot to have DVT2 technology available, and deployed by Arqiva. So for this first deployment, they was using Enensys modulators. Then a private operator in Italy deployed DVT2 as well, Ropasete. Sweden has also been deploying on a nationwide network DVT2 the same year, in 2010, so a bit more than 2 years ago. And since that time, you see that we spoke about DNA with our friends from Ericsson. Ukraine as well has deployed. Another large deployment in Africa that I will mention a bit later because it's the largest DVT2 deployment so far. It's based in South Africa. It's covering 15 countries. And so he's been started commercially a bit more than 1 year ago. So it's the largest deployment worldwide at this time. So as you see, a lot of deployments going on, a lot of companies, a lot of countries which have already selected DVT2 as their official choice for the DTT deployments. So this list is basically growing on a monthly basis. This is the status as of today. Especially in Africa, there's a strong push for DVT2 because they started at the stage where DVT2 was available. So now they are starting their new deployments all using DVT2. But as you see, this is now the widely accepted standard worldwide for DTT deployments. One important point for this type of deployment, of course, is the cost of the receiver. And the cost of the receiver for DVT2 has been surprisingly decreasing very, very quickly. We've seen set-top boxes, either high-end IDTV, high-end set-top box with a PVR, or very integrated set-top box that are available now for down to 20 euro the box. So really, the cost of the receiver is definitely not the issue when you choose DVB-T2 today. So this is very important because we know it's a strong choice of factor of choice for this type of solution. So there are millions of T2 boxes all around the world, either very high-end or very cheap as well. So let's go back to the basics. What is DVB-T2? So I will compare mostly with the existing technologies. So very important when designing DVB-T2, the DV group in 2007, they decided that this technology had to be able to reuse as much as possible of the existing infrastructure. So reuse the existing aerials, reuse the existing amplifiers as much as possible. The idea was not to reinvent the wheel, so the best of existing technologies has been chosen. DVB-T was, and is still a very good technology. OFDM has been chosen as the basis for DVB-T2. Now in DBS2, as Newtek just presented, there are very interesting concepts that had been proven. And so the best of DVB-T and DBS2 has been put together to create this DV2 standard, which allows to gain a lot. I mean, the initial goal was to gain at least 30%. Of course, when you define a new technology, it has to be better than the existing ones. So the threshold had been set to 30% of gain. This was the goal, the initial goal. And we'll see that in the actual test, in fact, we outreached this goal by far. So in a glance, I won't go into the details of that, but in a glance, we can compare DVT by DVT2 with mentioning that there are lots of new things in DVT2. All the things in bold here are new. So there are much higher figures, for example, for FFT size, for constellation, so much more choice, which makes DVT2 more flexibility because you have more choice and more capacity. You can go higher in terms of modulation and capacity. So when you choose DVT2, you choose a technology that has a lot of options, a lot of capacity. So you have to choose which are the ones that you want to use. So comparing, I take a case here to compare with the same goal, the capacity of two technologies, DVT and DVT2. So these are the parameters that have been chosen in UK to deploy their new multiplex. So they make the choice, this choice in DVT here, which allows to have 24 megabits per second on one frequency. With DVT2, they made the choice of the parameters for the same coverage, so exactly the same coverage in DVT2 as in DVT. They can go up to 40 megabits per second. So what has been measured, what is the reality today, is that, in fact, the capacity of T2 compared to T it's not 30%, it's 66%. So that's really a very, very high gain that has been achieved by having exactly the same coverage, but allowing to have more bitrate. This is not the only choice that you can make. As we see here in this diagram, you can have the same coverage, so either more bandwidth or the same bandwidth and reduce the transmission power. It's another possibility. You can choose to have also more coverage if you want to have, for example, some indoor coverage which is not achievable in DVT. With the same power, you can reach indoor coverage. So you can either have more bandwidth or the same bandwidth with more coverage. So there are lots of parameters on which you can play in order to use your resource, your frequency resource, as efficiently as possible. You can play on the coverage, you can play on the bandwidth, and you can make a mix of both. So now, what is the difference when you deploy a DVT network and DVT2 network? So DVT network, well, basically you have encoders, multiplexers, a video head-end here. You need an SFN adapter at the head-end in order to synchronize and to deploy SFN networks. And then you have a DVT modulator on the transmitter side. Well, in DVT2, in fact, it's very close to that. I mean, basically what needs to be done is that you replace SFN adapter here by a T2 gateway, which does the SFN adaptations. It does more things, but this is one of the features that is provided by the T2 gateway. And you need to replace the modulator, the T modulator, by a T2 modulator. And I would say basically, this is it. You've done that. You've upgraded your T broadcast into a T2 broadcast. Well, in fact, this is not the only difference. One of the big difference is also the receiver. Because the receiver, the T receiver cannot receive a T2 signal, which is not the case for the T2 receiver, which can receive the T signal. So basically, these are the differences here that are needed in order to deploy a T2 system compared to a T system. So what are, in a few words, the technical advantages of T2 compared to T? Well, first, SFN has been improved. So SFN is very interesting, very good in terms of efficiency. It has been improved in T2. There are tools that allow to have better SFN deployment. There is one capability which is very interesting and which is derived from DBS2 with a multi-channel. It's a multiple PLP. Well, multiple PLP basically allows to do what is displayed here. You have one frequency, which is a big pipe here, displayed in blue, into which you can put several smaller pipes, each of these smaller pipes allowing to carry a different transport stream. So, which means that you can have different transport streams carried into one single frequency, each of these transport streams having its own modulation parameters. So you can really use your frequency in a much more modular way than in DVT. Because in DVT you have one frequency, one transport stream, the T2 gateway, and the modulators. So this protocol allows to carry multiple PLP streams. It allows also to manage the synchronization, the SFN, and it allows to remotely control all the modulators from the gateway. So these are, I would say, three key improvements of T2 compared to DVT. To go into more details on this multiple PLP capability, you see here in DVT, one frequency, one transport stream. In DVT2, one frequency, several transport streams. So you have much more transport streams that are possible and much more flexibility in the use of each of the frequencies. One of the things that have been added to DVT2 is what is called T2 Lite. T2 Lite is basically a way to modulate the signal for reception by mobile receivers. So T2 Lite can be carried, if you look at here at the multiple PLP, you can carry one PLP here as a T2 Lite PLP and other PLPs that can be used for fixed reception, for example. So it's possible to mix in a single frequency a broadcast for mobile receivers and broadcast for fixed receivers. So multiple PLP allows to use the terrestrial networks in new ways, in ways that were not possible previously with DVT, which allows to have new business models for the terrestrial networks. The first one is to have a PLP covering different areas. From a central transmitter, you can cover with PLP1 a small area. For example, if you want to have a very robust coverage of a given service, given channel, you can broadcast it in a smaller area and have another PLP with the same transmitter, the same amplifier, from the same tower, covering a larger area. This is one possibility, to cover different areas from one location. Another possibility which opens many new doors is to have, with a single frequency, reception targeted at different type of devices. Here we see in the house, the reception here in the living room, it's a big HD screen. You have rooftop antenna for that. So you need one very high bitrate stream with good facility for reception because the rooftop is easy to receive. Here you have the smaller TV set in the room, which is not connected to the antenna. It's connected to a small antenna, which is on top of the TV here. So it's indoor reception, lower bit rate, so not another type of reception. And then the third type of reception can be, for example, for a radio receiver, so lower bit rate, but even deeper indoor reception. You want to receive your radio anywhere in your living house. So all these three types of services can be combined together, each in a separate PLP with different modulation parameters in a single frequency. So this is a possible use of multi-PLP on the terrestrial network. Another one that we have seen in some countries is to be able to share one frequency between several operators, which is the case in many countries. You have frequency which is shared between several operators. It's possible here to allocate a PLP per content provider. So in this example, you have 3 content providers. Each content provider has its own, I would say, percentage of the resource, and it can use it however it wants. It means that one content provider can put, for example, 2 HD channels with rooftop reception, so not so strong modulation scheme. Another wants to have many channels with easier reception. So all of that can be combined in a single frequency. So this is a business model which is interesting in certain type of configurations. Another possibility is to use the multiple PLP as a way to handle regional content. In many countries, you have nationwide services and also services which are on the regional basis. Using multiple PLP and the PLP substitution technology, you can, on each transmitter, make a substitution of one PLP carrying one region by another PLP carrying another region, allowing to build a network with the transmission of all the channels once, for example, over the satellite, and combining on a SFN cell basis on each region, combining national and regional services. You can do that by using the multi-PLP and the PLP substitution technology, which allows to build SFN networks and replace one PLP by another one. So this is a capability that is very interesting, especially in large countries or large areas where you need to have coverage of very large areas and regional management. Another business model which is very interesting in DBT2. So let's go now to the solutions that Enensys provides to deploy such architecture. This is a diagram showing all the products and the way to combine them. We have set up a demo in the back of the room here. So there are a number of equipment that are on display that I will be able to show to the people who are interested later. Well, basically, there are equipments on the head-end side here, which are needed to build a DBT2 network, and products on the transmission sites as well. So on the head-end side, the central product is the T2 gateway. The T2 gateway basically is taking as input the transport streams out of the MUX, and it's creating the T2MI stream to be sent to the transmitters. So the T2 gateway is synchronizing, so it's doing the same work as the SFN adapter in DBT. It's inserting the timestamp in the stream. It's creating the physical layer pipes, the PLP, so you can have several transport streams at the input, and the PLP are created in the gateway and output as a single T2MI stream. And of course, the T2MI stream is generated by the T2 gateway. So these are the main features of the gateway. The gateway is really mandatory when when you build SFN network, because it's really the device that is allowing the synchronization of the transmitters. So you really do need the T2 gateway when you build an SFN network in DVT2. When you use multiple PLP, because the gateway is creating, this PLP combination that I just described. And also when you want to use the T2MI, when you want to remotely control all the transmitters from the head end, this is mandated as the gateway is generating this T2MI stream. There is another device that is, I would say, companion to the gateway, is the switch, the seamless switch, because as you can guess, this device is very central, very strategic in the system. If it breaks, the whole system stops. So we have proposed a 1+1 redundancy solution, which allows to have two gateways in a 1+1 scheme and one switch here. And this switch basically takes the input from the gateway and allows to have, for example, two different paths to resynchronize them and to have one output here. Or it allows to have two gateways at the input and generate one stream, switching from one to the other in a completely transparent way for the system, what we call seamless switching. We have the same product in the IP domain because more and more systems are deployed using IP as a standard connection. So we have the IP guard here, which is the switch in the IP domain, allowing to do the seamless switch with IP outputs. The T2 Edge is a product which allows to do the PLP substitution process that I described previously in order to have regional management. So you can take one regional stream here and replace in the stream to have your regionalized stream at the output, which allows to do this kind of things. For example, national head end and two regional head ends transmitted by satellite. And you have the T2 Edge on the transmission side, which is doing on this cell here replacement of this region 1, and on this cell, this region 2. So with the same nationwide system of services, you can build in two regions, two different broadcasts, using the same connection here, the same broadcast. So this is the T2 Edge which allows to do that. It takes the national TV, the local one, and it replaces, here it displays the PLP. So it replaces PLPs that are in the incoming stream here by these ones. So at the output, you have a different combination of PLPs. This is done at a transmitter level. So each transmitter can do its own region replacement. Then we have the referee. We have also in our test and monitoring product line an analyzer, which can be put any place in the network in order to monitor and to analyze what is broadcast. So basically, it's a small box that you can see on the back here, on the back of the demo, we have one of them. It's USB powered, so it's very, very easy to transport. RF or ASI input. And you have a lot of software on the PC that allows to decode, to display, to show the SI tables, to show the video. I would say to see what is being broadcast on the frequency that you're analyzing. It's a very, very easy to transport device and very powerful as well, as it provides a lot of analysis features in a very small enclosure. So as a conclusion, we've seen that DVT2 is really extending DVT. It allows much more efficiency in the use of the frequency resource, and it is completely transport agnostic. I mean, it can transport MPEG-4, HD streams, 3D TV streams, whatever content that is needed to broadcast. It's more robust, it's more flexible, We've seen the new business model it allows, and it's obviously more bandwidth efficient. The business models that are provided by multiple PLP, we strongly believe that it's one of the very, very strong advantage of the DVT2, as it allows to leverage on terrestrial networks and to really implement innovative services on a terrestrial network. And importantly, I mean, DVT2 is a reality today. It's been deployed. There are very large networks, cheap set-top boxes in many countries in the world. It does exist. And, well, DVT2 is more than on its way for a success story. It's really a success story already, and it's definitely the 21st century choice for digital terrestrial TV networks. So there is a demo setup that we have in the back. So anyone willing to have more details on the products is welcome to come and see us at one of the breaks. And I would like to thank you for your attention. And if you have any questions, you're welcome. Thank you.